Morning to one and all present here. So, I am going to discuss about the topic MO theory of oxygen molecule. Myself is Dr.C.Thangapriya, Assistant Professor of Chemistry in SFR College Sivagasi. We already in the previous class we already discussed about the what is meant by MO theory, how the molecular orbital form. We already discussed in the previous video. MO theory discuss more about the bond character, bond order, bond length of an covalent, most of the covalent molecule. Nowadays it is applicable to the coordination complex also. So, we simply discuss here about the some simple covalent molecule, hydrogen, oxygen, nitrogen, boron, which having the bond covalent bond character present between them. So, here we discuss about here the MO theory of oxygen molecule. So, now go to the MO theory objectives. So, what are the topic we covered in this section is, so first of all we discuss the MO theory of O2 minus and the MO theory of O2 2 minus, MO theory of O2 plus. Then we have to discuss about their bond order, bond length and the magnetic characters. Bond order, we already said that bond order it represents the number of bond present between the two atoms. From the bond length we can say whether they having the single bond or double bond character or triple bond character. From the magnetic character we can say that whether the molecule having a paramagnetic, that is magnetic character present or not, can also be we can determine from this MO diagram. MO diagram for O2 molecule. So, first before going to the oxygen molecule cation and anion, first we have to discuss the MO diagram for the neutral molecule, that is the O2 molecule. We are all know that the oxygen having an atomic number 8 and having an electronic configuration of 1s2, 2s2, 2p4. So, when to form an oxygen molecule, 2 oxygen is combined to form an O2 molecule. So, in the MO diagram, when the one oxygen atom is present in the left side, one atomic orbital of one oxygen atom is present in the left side, and in the right side the atomic orbital of another oxygen atom is present in the right side. In the center we having the molecular orbital, that is the 2 atomic orbital is combined to form an molecular orbital. How many atomic orbital is combined is equal to the number of atomic orbital molecular orbital formed. Suppose if 1s atomic orbital or 2s atomic orbital of 2 oxygen atom is combined, we get 2 molecular orbital. It is represented in the MO diagram of oxygen molecule. Here we discuss that atomic orbital combination of 2s atomic orbital and 2p atomic orbital, that is the 2s atomic orbital having 2 electrons in its orbital, whereas 2 atomic orbital having a 4 electron in its 2p orbital. Similarly, here the other oxygen atom carrying 2s orbital and 2p orbital. First, when the 2s orbital of one oxygen atom is combined with the 2s orbital of another oxygen atom to form an 2 molecular orbital, one is sigma 2s and another one is sigma star 2s. That star means sigma star 2s means it is an anti-bonding molecular orbital which is having a higher energy compared to the bonding molecular orbital sigma 2s. We already discussed in the previous video. Then the 2p orbital, here the 2p orbital having 4 electron, here also the another oxygen atom also having the 2p orbital 4 electron. So, totally 6 atomic orbital is overlapping. So, this 6 atomic orbital is overlapping to form the molecular orbital sigma 2p and pi 2p orbital. Here the pi 2p orbital having the 2 molecular orbital which having the same energy. Similarly, they having the corresponding anti-molecular orbital. So, their MO diagram is represented here. So, the MO diagram is represented here. The sigma 2s, sigma, the following at the molecular orbital for oxygen molecule is sigma 2s, sigma star 2s, sigma 2p, pi 2px, pi 2py. Similarly, pi star 2px, pi star 2py and sigma star 2pz. now the electron is filled in this atomic orbital based on the Hund's rule and the off-off principle. It is said that the electron is filled from low energy level to the high energy level. So, the electron is filling from sigma 2s orbital and then to the sigma star 2s orbital. Then the remaining electron is go to the sigma 2p z orbital, then it is filled to the pi 2p orbital. Here the pi 2p orbital having the two energy orbitals having the same energy level. So, here the Hund's rule is applied. So, based on the Hund's rule, when there is an two energy level orbital having the same energy level, the electrons are filled first, having the electrons are filled first in the half filled nature, that is each orbital having an half filled completely half filled, then the remaining orbital is then filled. Here it is filled phi 2px to pi 2py2. So, the remaining it having two electrons, it is go to the anti-bonding molecular orbital pi star 2px, pi star 2py. So, this is the MO diagram for the oxygen neutral molecule. There is no charge carried over that molecule. So, next we discuss the bond order. So, the bond order we already represents that it represents the number of covalent bond between the two combining atoms. So, the bond order calculation is Nb minus Na by 2, that is the number of electron present in the bonding molecular orbital minus the number of electron present in the anti-bonding molecular orbital divided by 2. So, when applying this formula to the MO diagram for oxygen molecule, the oxygen molecule having the how many electron in bonding molecular orbital is, it having the sigma 2s bonding molecular orbital, sigma 2px bonding molecular orbital, pi 2px, pi 2py bonding molecular orbital. So, totally here we having 8 electron present in the bonding molecular orbital. The remaining 6 electrons is filled in the anti-bonding molecular orbital. So, here it is represented as, so by applying the formula we get the bond order is 2. So, from the hence the bond between two oxygen atom in O2 molecule is 2 and it is represented in the diagram as O double bond O, one sigma bond and one pi bond. In addition to that, we have discussed the magnetic character. So, here having an two unpaired electron is present in that pi star 2px and pi star 2py orbital. So, due to the presence of these two unpaired electrons, it is having the paramagnetic characters due to the presence of these two unpaired electron in the oxygen molecule. So, now we discuss the anion of oxygen molecule. It is represented as O2 minus. So, this O2 minus having the one more electron is present excess in the MO diagram. It is represented here in this diagram the pi star 2px and pi star 2py having the 3 electrons in having present in their anti-bonding molecular orbital. Whereas in the O2 molecule only 2 electron is present in the pi star 2p and pi star 2px and pi star 2py molecular anti-bonding molecular orbital, whereas in the O2 minus here the 3 electron is present in the anti-bonding molecular orbital. It is represented in the diagram pi star 2pxy having 2 electron, pi star 2py having the 1 unpaired electron. That is O2 minus means minus represents it having one more electron present in the anti-bonding molecular orbitals. So, it is represented in the diagram. Now, we apply the bond order for this O2 minus molecule. We obtain the bond order of 1.5. So, for the bond order of 2.5 for O2 minus ion, 1.5 for O2 minus ion. Similarly, for the next one, this is a bond order for O2 plus. O2 plus means one electron is removed from this neutral molecule of O2. So, this is a MO diagram for O2. For O2 plus, that is O2 plus means one electron is removed from the anti-bonding molecular orbital. So, the electron is removed from the pi star orbital which is present in the which having the anti-bonding character. So, the MO diagram having the pi star 2px 1 and pi star 2py, there is no electron is present for O2 plus ions. So, the bond order for this molecule is, the bond order for this molecule is 10 minus 5 by 2 which is equivalent to 2.5. So, for the bond order for O2 plus ions, the bond order is 2.5. Similarly, we can also discuss the bond order for O2 minus ion. So, the for O2 2 minus ion, one more electron. In O2 minus ion, the one electron is present in the pi star 2px, that having a 2 electron, pi star 2py having 1 electron, but for O2 2 minus ion, one more electron is present in the pi star 2px. So, totally 4 electron is present in this anti-bonding molecular orbital. So, the bond order is further reduced for the O2 2 minus. For O2 minus, the bond order is 1.5. But for the O2 2 minus, the bond order is 1. So, from this we conclude that the bond order for O2 is 2, whereas the bond order for O2 plus is 2.5, whereas the bond order for O2 minus is 1.5, whereas the bond order for O2 2 minus is 1. So, from this we conclude that the O2 molecule having the more bond strength character in the neutral molecule, whereas in the for the cation as well as for the anion, the bond order is decreased. In addition to that, we already discussed that for the neutral molecule, the magnetic character is paramagnetic, because due to the availability of 2 unpaired electrons in the O2 molecule, having 2 unpaired electron in the anti-bonding molecular orbital. So, it having the paramagnetic character, whereas for the O2 minus, it is having only 1 unpaired electron. So, it is also having a paramagnetic characters, whereas for the O2 2 minus, we have one more electron is present in the anti-bonding molecular orbital. So, there is no availability of free unpaired electron. So, O2 2 minus having an diamagnetic character, whereas O2 plus, it is also having one unpaired electron is available in the anti-bonding molecular orbital. So, it is also having an paramagnetic character. So, from the magnetic character we conclude that O2 2 minus only having diamagnetic character, the remaining O2, O2 minus, O2 2 minus all are having an paramagnetic characters. So, from this this is all conclude from the MO diagram of O2 molecules. So, this is a bond order calculation for O2 plus. So, from this we conclude the molecular orbital diagram for oxygen molecule as well as for its cation and anion. Thank you.